Okay, so I've shared the screen. This very first thing is not a question, it's just for your understanding. I just wanted to talk about a back-to-back stem and leaf diagram. Okay, so let's understand the scenario and let's see for which questions exactly we would be making back-to-back stem and leaf diagram. Okay, so far the cases which we discussed had one scenario only, right? But if you have two types of data, let's say like here we have two types of data. One says people who exercise and then it says people who do not exercise. Okay, so it means we have two types of data. Now if you are asked to represent this data through a back-to-back stem and leaf diagram, it's just like how we do it for simple stem and leaf diagram. So yes, I will just add the comments. All right, okay. So yes, so this is for people who exercise, and then this is for people who do not exercise. Okay, let's look at the key. There's no point in reading all the scenario. Let's look at the key. So key says 2-8-1. This thing represents a cholesterol count of 8.2 in the group who exercise and 8.1 in the group who do not exercise. Let's go and see where exactly is this. So this is 2, then this is dash, this is 8, and then this is dash. Okay, this number is going to be the first one. The dashes would be same. Okay, if this dash is basically representing a decimal number, then the other line would also represent a decimal number, right? So if it is, let's say if it is 4-9-1, 4 is written on this side where we have people who exercise, so it would be 9.4 for people who exercise, and it would be 9.1 for people who do not exercise, right? This is how we interpret this table. Everything is same. The counting for people who do not exercise is separate. The counting for people who exercise is separate. It is again in ascending order. Every other thing is same. The only difference is that for this, we are representing two types of data in one stem and leaf diagram. So in most of the cases, the examiner is going to give you the stem and leaf diagram. It could be that he's asking you to make it, but yes, in most of the cases, you would be asked to play with this type of data and find mean, median, mode, interquartile range and stuff like that. Okay, so it's not that different. Everything is same. The only difference is we have another data type, the representation, the key, everything would be same as it was initially. Yes, any doubts with this back-to-back stem and leaf diagram? Any questions?
No.
Vishal, is this okay? Okay, and you can even notice that the counting for people who exercise is separate and the counting for people who do not exercise is separate. So just think about it as if you have two opposite data sets, right? One is for who are doing exercises and the other one is for who are not doing exercises. So two separate, two different, completely opposite data sets, you can represent them through a back-to-back stem and leaf diagram, because that would help you in multiple things, you know, in analyzing the data and observing everything. So you would be able to make comparisons directly. Okay, this was just a discussion. Let's talk about the first question. Okay, here's the first question. So what exactly it is? The pulse rates in beats per minute of a random sample of 15 small animals are shown in the following table. So this is the data. Draw a stem and leaf diagram to represent the data. Okay. The very first thing which we need to understand is that this is just one type of data, so we would not be drawing back to back. And if the examiner would want you to make back to back, he would specify that. Okay, So a simple stem and leaf diagram is what we discussed in the very first class, and a back-to-back stem and leaf diagram is what I just explained you guys. Okay, let's make it together. So we know we need to keep a few things in our mind while making stem and leaf. The first thing is the ascending order. Let me make this thing. All right, okay. So here this would be the stem, and this is going to be the leaf. Oh, all right, okay. So yes, what is the smallest number? It is 104. 104, okay. Now, as I told you earlier as well, in the leaf part, we will only write down one number, okay? So 10 is going to come here, then 4, comma 4, okay? Then what number is next? It's 9, 109.
9.
So 109. And are we done with the 10 series? Yes, we are done. So we will write down the total count. That is 1, 2, and 3. 3 numbers in the first row. Okay. Then we'll write down 11, and we have 115, 117. Okay, so it would be 5, it would be 7, and how many numbers?
2.
2. Very good. Then we have 12. Okay, 120.
0.
And 124, 125. Very good. 0, 4, and 5. So this is 3. Okay, and it's good that you encircle, you underline, you tick those numbers which are done, just so we don't look at them again and again. So this 115 is done. Yep, okay. Then it says 13. So do we have? Yeah, we do have. It's 130. It's 132. It's 134. Yeah. So 2 and 4. So it would be 2. Then we have 14. So we have 145 and we have 142. So it would be 2, 5. It's 2. Then I'll write down 15. And then we have 158 only. So 8 would come.
1.
Yeah. And this is 1. All right. And then we have 16.
16.
So 160.
0, 2.
Very good. And 162. 0, 2, and it should be 2. Now, it is a 3-mark question, and it's good that if you spend, let's say 5 minutes at least. So if you have, let's say, a few seconds left, you can just take some seconds and just count this and make sure you get 15. Okay, because at times this is the most popular or most common problem which every student does, is that whenever they have raw data, they are missing out a few numbers. Okay, so that is not a good idea. Just count this: 3 plus 2, it's 5, then 5, and then 5, that would be 15, and this is correct. Okay, so this is how we make stem and leaf diagram. Yes, Shalin, Munja, any doubts with this first question?
No, ma'am, thank you.
Okay, now we have missed something, and that something is the key. Okay, key has a proper separate mark. We need to write down the key always. So how do we write it down? Just pick up any number. Let's say I pick up 13.
16.
So it is going to be 13-2, and it would be 132. All right, okay. This is how we do it, okay?
Okay.
Yes. All right, Ishal, please check your camera. I think it is on. All right, let's talk about the next question now. It says, A library has many identical shelves. All the shelves are full, and the number of books on each shelf in a certain section are summarized by the following stem and leaf. Now, this time around, the stem and leaf is given, okay? Find the number of shelves in this section of the library. Yes. It is a 1 mark question. Think about it and then just answer it directly.
Mm. Oh, do you have to add the 4 to 420, the values?
Yes,
So to
because
find
it
the number of
says
shelves.
the
Yeah.
number of books on each shelf in a certain section are summarized. Okay. So on one shelf, we have 33 books, then 36, 39. So you need to add them up. Yes, Ashal,
Yeah.
please add them up and tell me the value for the total number of shelves.
4 plus 4, 8, 10, 20, 30, 42, 49, plus 17. 7.
Very good. Both of you. It is 67. Okay. Now the next part is draw a box and whisker plot to represent the data. Now we need to do this. So for a box and whisker plot, we need 5 things. Okay. We need
Yeah.
the minimum value. We need the lower quartile. We need the median. We need the upper quartile, and then we need the maximum. Okay. So yes, what is the minimum number? Since this is stem and leaf, it's very obvious.
33,
Very good. And what is the maximum one?
99.
Yes, that is correct. Okay, now for the median, lower quartile and upper quartile, I'll give you 3 minutes. Please do your working and just type the answer in the chat box. I'm there. If you have any confusions, any problems, just stop me and ask me. But for now, I would want you guys to calculate these 3 things and then we'll make the box and whisker plot.
Mm. 70.
So Vishal, please check that again. No, for the median, what do? We do n plus 1
Plus
divided by
1.
2. What is your n? Whatever the n is, add 1 divided by 2, you will get a number. Look for that number
It's
of
the,
term and then just
it's the
find
third
the
fourth,
median.
third fourth value,
Yes,
which is
yes.
73.
Very good. Yes, Ashal. Yes, Munja and Ashal, very good. It is 73, okay? The median would be 73. Very good. Okay, now work for the lower quartile and upper quartile.
Low quartile, it's also 0.25 of the median.
Yes, what is the lower quartile? Sorry, I missed it.
64.
Very good. Yes. And yes, Ashal, can you tell me the upper quartile, please? I'll wait for another minute. Just find the upper quartile. Yes, very good, Ashal. What about you, Munja? What is the upper quartile?
80.
Upper quartile, the value.
80.
80. It should be 90, okay? Just check that again. I think you did some small mistake. Okay. All right. Let's check this again.
Oh,
Now,
okay.
in the classes, we discussed for finding the lower quartile and upper quartile, it would depend on odd and even data. We will eliminate the median first and that way. Yes, that is obviously an appropriate method, but another method could be that for the upper quartile, you do 3 by 4. This is what we discussed as well, n plus 1, and this would give you 3 into 68 by 4, and this would be the 51st term. So we are looking for the 51st term in order to find the upper quartile. So where exactly would be the 51st term? We have 10, then 30, then 42, then 49 terms, and then it is going to be 50th and 51st. Okay, so this is the 51st term, so it would be 90. And for the lower quartile, you can do 1 by 4 n plus 1 directly. So this would give you 68 by 4, and this is going to be the 17th term. So where is 17? 4. Okay, this is 10, and then 11, 12, 13, 14, 15, 16, 17. Okay, that is why it was 64. So yes, this is what I wanted to add to this thing, and these formulas are important, and it's better that we use them instead of just thinking about it on its own, that we have eliminated median and now we need to find the median of the upper half and lower half. That is correct, but that takes time. It's better that we use this formula directly and do it. Yes. Once we have these five things, this is what we call five data summary. You need to make the box and whisker plot. Okay. So for making an appropriate diagram, I would be shifting to my whiteboard. So I'll stop sharing this. I'll write down everything there and let's do it there. Okay. So as I told you earlier as well, we need five things. The minimum value, that was 33. The lower quartile, that was 64. Then the median, which was 73. Then the upper quartile, that was 90. And then the maximum value, that was 99. This is what we had. Okay. And now in order to make the box and whisker plot, we just need to make a line. I'll make the box first. All right, now let's do the labeling. It's going from 33 to 90. So this is going to be 64. This is going to be 90. If the examiner, since it is plot, so the examiner would be giving you a grid. Whenever you have a grid, you need to be careful while writing down the excess that would have a separate mark. You cannot just write down 64 and 90 over there this way, okay? You need to count the boxes and check everything. And you know what scaling is through that. You need to just make sure that every box is of equal value and stuff like that, and we'll talk about that later. At the moment, let's see how to make a rough sketch. Okay, and then the median is 73. So 73 is closer to 64. So it should be somewhere here. So it is 73. Then I am going to add the minimum value. That was 33. And then I'll be adding the maximum. That was 99. Okay, now my diagram is not doing justice to what we exactly have. This is approximately a difference of 30 numbers, and this is a difference of 9 numbers, okay, which is not that obvious here because I'm just making a rough sketch to explain you. Otherwise, in the exam you would be given a grid. When you'll be using a proper scale for that, obviously it would do justice automatically. Okay, so just to be more
Okay.
precise, let's try doing it. So yes, this could be 99. This is 99, and then that is 33. Okay, so this is how we make box and whisker plot. This one is the lower quartile, this is the median, the upper quartile, the maximum, and the minimum. Yes, Ashal, any doubts with this? All right, okay, I'll share the screen again. Okay, very good. So you can see that the question was not that difficult, but it was a 5-mark question. So as I've been telling you already, for statistics, you need to go with a fresh mind and you would be able to do it. Okay. Let's talk about the next one. Okay. Now this is, yes. Okay. Before talking about this, I would like to talk about expected value, which we certainly discussed yesterday, but still I feel like things were not that clear. Okay. Expected value is just another number which you can find. Let's say the question is about expected value of x. It's self-explanatory. Expected value of x. What are you going to do? You will sum up the product of x with the probabilities. Okay. If the question is about expected value of x squared, what are you going to do? You'll sum up the product of x squared with the simple probability that is given in the question. Let's say, obviously it would not be like this, but if the examiner is asking you about under root x, obviously he won't be, because this is not something which we do usually, but just for your understanding, this is how we are going to do it. Okay, so the probabilities are going to be same. This variable is changing and this is changing according to this one. So this is a simple formula for the expected value, which is important obviously because we are using this for finding out the variance as well. But yes, at the moment, let's just write down the formula and then we would be able to do it easily. So expected value is this, and expected value is also the mean. Okay, so in those questions, we'll talk about this later as well, but since we are talking about it at the moment, in those questions where you have probability and the question is about finding out the mean, so how do we do it for those questions where we have frequency? We do summation fx divided by summation f. So if I divide it by summation px, this would also give me mean. Since summation px is 1, that is why we do not write it down. So this is also my mean. I told you in questions where we have probability, things are just same as if you have frequency. The only difference is you have frequency and then you have probability. That is it. Otherwise, everything is same. Okay. Yes. Any doubts with this? Should I explain this again?
No.
Okay, Manja, I will explain this again. Okay. First important thing, expected value has a formula. It says summation x into probability of x. How would we be finding estimated value of x in this case? We'll multiply this, we'll add it to 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 this. That is it. Okay. Just like we do for summation fx. We are multiplying f and x first and then we are adding them. So this is how we do summation x into probability of x. The second important thing is that for finding out the mean, in these cases, we just find out the expected value and that is your mean. Okay. Why is
Okay.
that your mean? Because I told you probability and frequency, they are just same. Although they are not same actually, but for calculations and for working, they are same. Okay. So since for finding out mean in table data, this is the formula we use. Is that okay? Yes, Munya, this is the formula which we are using for finding out mean in table data.
Yes, yes, ma'am.
Okay. So for probability, I told you everything would be same. We are only going to replace frequency with probability divided by probability. And since sum of probabilities is 1, that is why we can write it down, but we avoid writing it down. So what would be this? What is this? This is the mean, okay? So the
Okay.
expected value is basically your mean.
Okay.
All right, okay. So it would get more clear once we do this example. Okay. Now, all these questions, I picked such questions on purpose because you guys would get to find them in most of the past papers. And yeah, that is it. Okay, it says the discrete random variable. Forget about what it means. It's just a variable x and it has the following probability distribution. Since we have not discussed other variables, that is why I'm not focusing on that at the moment. Okay. We have a table that has x and it has probability. Given that the expected value of x is 1.7, find the value of p and q. All right, now they have given the expected value and they want you to find p and q. This is p and this is q. Let's use this expected value and this formula. So expected value is summation x into probability of x. So expected value is 1.7. And for finding this out, I need to write down xp here. I need to multiply them and write it down. So this would be negative 0.4. This would be 0. This would be p. This would be 0.3 and this would be 4q. Very good. So I need to write sum them up because it says summation xp minus 0.4 plus 0 plus p plus 0.3 plus 4q. Let's just simplify this and this would give you 1.7 equals minus 0.4 and plus 0.3 minus 0.1 plus p plus 4q. Very good. Okay. Now I'll take the 0.1 to the other side. It would give me 1.8 equals p plus 4q. Very good. This is the first equation. Now, obviously, I do see that I have two unknown variables, p and q. This is the first equation which I got from this piece of information, and we do not have any other thing. So how do I make the other equation? Can anyone tell me? It is linked with probabilities. That is your hint. We know a fact about probabilities. We know a property about probabilities. That their sum is equal to Yes. What is this? What is the
It's got
sum
one.
of? Very good. Okay. So we can use this since sum of all the probabilities. I'm telling you right now, this could be a 1 mark question in every question of this type where you have probabilities. Okay. The
Yes,
examiner
ma'am.
would certainly test you for this. So it would be 0.2 plus 0.1 plus P plus 0.1 plus Q equals 1. So what have I done? I've just added up all the probabilities and I've equated that to 1 because I know sum of probabilities is 1. Now we need to simplify this, Ashal. Please pay attention. It would be
0.1
0.4 plus P plus Q equals 1, and P plus Q is going to be 0.6. Now these are your two equations. I'll give you 2 minutes. Let's just do some practice for pure maths as well. Just solve them simultaneously and find the values of P and Q.
Q is got 0.4. And
Yes,
P is
Munja.
got 0.2.
Excellent. Okay, the Q is right. Okay. Ishal, can you please tell me the value for P?
0.2.
Yeah, I'm not sure. I want Ishal to answer this.
Oh, sorry.
No, that's okay. I just want all of you to participate. Q is correct. Just check your P once again. Yes. Okay. All right. Yes. Good. Munja and Ishal. Very good. P is 0.2. Very good. And Q is 0.4. Excellent. Very well done. Okay. This is how we do it. Okay. Now the next part is just a 2 mark question. Although calculating, yes.
Ma'am, can I
Yes.
just quickly put this one down
Yes.
before
Yes.
just 1 second?
Yes.
Okay,
Yes. Sure.
thank you.
Sure. I'll zoom out.
Okay. Thank you.
All right. Okay. So you can just tell me directly, okay, whenever you need to note down something. All right.
Okay, thank you.
All right. You're welcome. Okay. Now it is a 2 mark question. I always tell my students to focus on the number of marks because that would tell you if you need to do a lot of working or if things are there in front of you. Okay. You need to find the variance as we discussed yesterday as well through the probability using the probability table, and it's just a 2 mark question. Otherwise at least it should have been a 4 to, let's say, 3 to 4 mark question, right? Now if, since the question is direct, what does that mean? It means that you do have a few things already. How do we find variance? We discussed this yesterday as well. So either you can write it down this way: variance of x is equal to. Now let's do it. Okay, now this is variance. This is not standard deviation. So I would not be writing down that under root. Okay. So
Okay.
let's talk about the frequency first. It's good that you learn one formula and you would be able to use that again. So we do f into x squared divided by summation f, and then we do minus summation fx over summation f square. Any doubts with this formula? If there's anyone who still thinks this is wrong or stuff like that? Yes, Ashal and Munja, is that correct formula or wrong formula? For variance,
It is
when you have
correct.
free. It is what?
It is correct.
Very good. Okay. Now, as I've been telling you already, whenever you have f, you can just get rid of this and write down probability. Okay, wait, Ashal, I'll stop sharing and I'll screen again. I'll share the screen again. Ashal is not able to see the screen. Yes, I've shared the screen again. Can you see the screen now? Okay. So, Ashal, we're talking about variance. And you're welcome. And it is a 2-mark question. Forget about that. First thing is to write down the formula of variance. And this is when you have frequencies. If you have probabilities, you can directly just replace f with p. Okay, you will see. I'll just replace f with p.
Okay.
Now the fact that summation p is 1, I can write it down as summation px squared minus summation px whole squared. Okay. And now, since this is what we discussed in the very beginning, this is expected value of x. So I can write it down as this expected value of x square. And what is this? I told you, if you are interested in finding out the expected value of x squared, you do summation probability into x squared. So this would be the expected value of x squared, right? So this should be your formula in case of probability questions. This formula directly, and I've showed you the derivation. Yes, any doubts? I'll repeat once again. This is the formula which Munja and everyone knows, and you guys are comfortable with this. Okay. This is the case when you have probability instead of frequency. So I just said, forget about frequency, just write down P wherever you had F. This is what you will get. Okay. Then since
Okay.
summation P is 1, that is a property about probability. Sum of probability is 1. I just got rid of it because I know it would be 1. And once I removed summation p, this is what I had. And now this is what expected value of x squared looks like, this one. And this is what expected value of x looks like, this one, right? So whenever you have probabilities for those questions, it's a good idea to use the expected values for finding out the variance rather than going for the long formulas. Yes, is that okay? Ishal and Munja, any doubts with this?
No, ma'am. Thank you.
All right, okay. So I'll just rub this because this was just for your reference. And even if you were not able to understand anything, because derivations are not part of your syllabus, certainly, just trust my words and write down this new formula for variance. Because
Okay.
I'm not the type of teacher who wants, I would never want you guys to learn too many formulas, because this is why I chose maths. You don't need to memorize stuff. You can just, go from one formula to the other easily. But still, if you were not able to understand, it's completely fine. Just learn this. This is how we use expected value in order to find the variance. Yesterday, we were writing down under the root, because that was standard deviation. This is variance. Okay. Now, as I was telling you already, this is a 2-mark question, and there is some significance about the number of marks. It means that the working would be less. Let's scroll up and see how much work we need to do. Expected value is already given, 1.7 square. So it is 1.7. Since we square the expected value, I'll square this and minus. And I need to find this thing. How do we find expected value of any variable? We need to multiply that with the probability. So first,
Yeah.
I need to write down that variable. It would be x squared. So minus 2 squared would be 4, 0, 1. 3 squared would be 9. And 4 squared would be 16.
16.
Okay. Now I need to multiply the probability with x squared. So 4 into 0 0.2 would be 0 0.8. 0 into 0 0.1 would be 0. 1 into p. P was 0 0.2. So
Yeah.
1 into 0 0.2 would be
0.2.
0 0.2. Then 9 into 0 0.1 would be 0 0.9. And then 16 into 0 0.4 would be what?
0.4.
This would be
6.4.
6.4. Very good. All right. So this is how we do it. And now we need to add them up. So summation p x squared is going to be what? 0.8 plus 0 plus 0.2 plus 0.9 plus 6.4, and that would give you 8.3.
8.3.
Very good. This is 8.3. Now please simplify this and find the final answer and tell me what would be variance and what would be standard deviation, and just type the answer in the chat box. Okay, just type it. Shall check that again. It's 8.3 minus 1.7 square. Very good. Yes. And Munja, what is your variance?
5.41.
Very good. It is
Ma'am,
5.41.
if we
Yes.
square minus 1.7, won't we get a positive number?
Sorry, say it again. If you square.
If we square minus 1.7, won't
Exactly.
it
Yes,
become
you are right.
positive?
If you square minus 1.7 square, okay? Minus is in the formula and expected value is just 1.7. We are just squaring
So
1.7.
we're just supposed to square 1.7. Okay.
Yes, yes, yes. All right, okay. So let's talk about the next question now. Okay. Let's talk about this one. This is the last question for today. Okay. Let's understand this. It says, Munja, are you okay with this one? Do you need to note this down?
No, I've copied that from you. Thank you.
Okay. All right. Okay, perfect. It says a summary of n values of x gave the following information. Now you do not have all the table and all the raw data. You do not have any data. You just have the final information. This is summation x minus 20, that is 136. And this is summation x minus 20 squared, that is 2888. The mean of these n values is 24.25. Find the value of n. All right. So you have the mean, you have two pieces of information. You need to find the value of n. Okay. Now, how do we find mean generally? Generally, the formula for mean is summation x over n. Okay. But if you guys remember, I discussed this thing in the beginning that if you have, let's say, summation x minus a type of a thing, you can divide that directly by n and add a separately, and this
Okay.
is going
Yeah.
to give you mean. Do you
Maybe.
remember?
Yes, ma'am.
Very good. Excellent. Okay. So we are going to use the same thing again. This is what we have. So mean is going to be summation x minus 20. Since generally we have summation x, so we need to do something to balance out this minus 20. So we are going to add 20. And
Yeah.
the mean was 24.25. Summation x minus 20 is 136 divided by n. We need to find that plus 20. So now I can take this 20 to the other side. This would become 24.25 minus 20 equals 136 over n. And this would be 4.25 n equals 136, and n is going to be 136 divided by 4.25, and the answer is what? It should be 32. Just make sure if you guys are getting 32 or not.
Yeah, it is.
Okay, very good. Okay, now the next part of this question is not that straightforward. This is something I'm telling you directly. Let's see how to do it. And this is why it is a 4-mark question. Okay, this is why I'm telling you guys again and again, just focus on the number of marks. Find summation x squared. All right. So summation x squared. Now this is the x squared thing. And certainly if you say that, ma'am, if we add 20 square, that is not going to give you summation x squared. Okay, that is certainly not going to give you the summation x squared. Okay, so we need to do something else. All right. Okay. Now, for this question, your hint is that you need to find the variance using the given data and then use variance to find summation x squared. How? I'll tell you. So for the variance, if you are, what is the formula generally for variance? Like we have a formula for frequency question, separate one, probability question, separate one, and the general one, the one which we discussed in the beginning of yesterday's class, it was summation x squared divided by n minus summation x over n squared. Okay, now it's simple. If you do not have f, just remove it, and then in the denominator, since summation f is n, so we are writing down n. Okay, this is the simplest formula for variance. Okay, we're talking about the variance at the moment. You will see why I'm using variance. This is the formula. So if somehow I get to know about the variance, I would be able to find this as well, because this is nothing but the mean. I have mean, it's 24.25, that is given. All I need is the variance. Somehow if I'm able to find the variance, once I have the variance, I have n as well. I just calculated that in the previous part. I would be using all that to find summation x squared. Are you okay with the strategy about this question? I'll repeat. This is how we find variance. Summation x squared over n minus summation x over n whole squared. Always remember, in variance, this would be your mean. Okay, we have been talking about different formulas, and every time this turns out to be the mean. This is going to be your mean. Now if we somehow find the variance, we would be having the variance. We already have n, and summation x over n is the mean. This is what I'm telling you again and again. Okay, so you would be
Okay.
able to find summation x squared easily, and this is the question. The only debate at the moment is how to find the variance. Now, what if I say that you can use this and this directly? Okay, and now I'll tell you. This could be a formula for variance, and then summation. Wait a second. Yeah. Summation x minus a squared divided by n minus
Yes.
summation x minus a over n whole squared. As long as this thing is subtracted in both of them, you are going to get the correct answer. Your answer would not be affected by this minus a. So you can use this to find the variance and then use the variance in this formula. Yes, do you get this, Munja and Ashal?
Yeah, I'm getting there.
Okay. Are you okay with this thing, the first formula which we discussed?
Yes, ma'am.
Okay. For the second one, this is what I'm telling you, that this is how you can find variance. Now, in the first formula and the second formula, the only difference is instead of x, I have x minus a. And I can do this because it is mathematically correct, because this minus a is with both the x's. So this is not going to affect your answer. Okay, let's do it.
Okay.
So summation x minus a. Now in my case, a is 20. Let's write, just replace a with 20. This was a general formula. It is 20 and then again it is 20. Summation x minus 20 is 288, 2888 divided by n. That turned out to be 32 minus, that is 136 divided by 32 square. Now 136 by 32 would not give you the exact mean. That is why I'm doing it here. But the fact that for variance, in the variance, all the variables are x minus 20. This is a rule. You can find the variance directly through this method. Okay. Just work out the variance and tell me the answer. What is the variance?
Okay.
Yes, Ashal, what is the variance?
$72.19.
Very good. 72.19. Very good. Okay, now we have the variance. So we can use this formula directly. Let's write it down as it is. All right. Variance is 72.19. Summation x square is to be calculated. N is 32 minus, we do not need summation x because summation x by n is given. It is 24.25. 24.25 square. Now you can make summation x squared the subject and you are going to get the correct answer. So it would be 72.19 plus 24.25 squared, and this thing would be multiplied with 32, and this would give you summation x squared, and that should be 21128. This is going to be your answer. Yes, Ishal and Munja, do you get this question? Okay, very good, Ishal. Munja, just focus on this new formula. This is why I suppose you are not able to understand it. Just try understanding this, okay? This formula would be used for this question. Since we have information about x minus 20, so that is why we are incorporating this new formula. Otherwise, we would have used the previous ones. But since we need variance in order to find summation x squared, that is why we are doing it this way. Please try understanding this question. You can just take a picture of this if you were not able to, because this is extremely important, okay?
Yeah, okay. Hang on.
Any questions that you would like to ask, Ishal and Munja?
Yeah, I'll go over it again, just to polish up.
Sure.
Yeah, but otherwise, I think it's not that difficult. Okay, I understand it now.
Are you sure?
Yeah, I'm just looking from the beginning where we started,
For the second part?
because I did get confused here where we started, just below the orange marker there,
Yeah,
where we
wait.
said the variance was
This
equal
this
x,
is the step
because you said
1.
288/32. Yeah.
Yeah, say it again. I
So
was not
now I
able to.
understand
Okay,
better.
now you understand this. Okay, all
Yeah,
right. So, and I'm
it is the
telling
mean.
you
It is
again and
the
again. Yes, in this was the mean. Yes, this is always the mean, and we know summation
yeah.
x, sum of all the x's divided by the
Mm.
total number of x would certainly give you the mean. Okay, that is the mean. This is how we
Okay.
define mean, and this would come in brackets. Ashal, you only need to square this, not the minus sign. And yeah, that is how we find summation x squared. And I'm telling you again and again, for statistics the pattern is not same. Obviously it keeps on changing, but more or less the type of questions is just this, because the syllabus for statistics is not a lot. So obviously the examiner has to give you same type of things again and again. So please try understanding these types. Do not memorize this, but just tell yourself that if this is how the examiner is asking you, this could be your possible strategy, that you need to use summation x minus 20 to find the variance, and then you can plug in variance, you have mean, and you can find summation x squared. All right, so I hope that this class was okay and you guys were able to understand these past paper questions which we did today.
Thank you, ma'am.
I will see you tomorrow. Okay, take care.
Okay. Okay. Thank you.